Welcome to the new episode, and today we will discuss tree data structure. So, in our last lesson, we studied about data structure, linear data structure, and non-linear data structure. And so far, we have studied linked list in detail. And now I will start discussing the tree data structure. So tree is also a kind of non-linear data structure, and this tree is actually like somehow representing the actual tree. Like a tree has a root, and then it has many branches and many leaves. So like every branch is represented using a node, and this last node in the tree data structure is called a leaf, like the actual leaf. So now you see the actual leaf, the actual tree here. Now let's see tree data structure. See, it looks like here, looks the same. We have a tree, we have a root, and then we have like branches. So we have branches. So there are different types of trees, of course, and within the context of this lesson, we will study very few types of them, which is the binary tree. See, an actual tree can have like many branches. Uh, like here in these diagrams also you see that some of the trees have like 4 branches, 2 branches, 3 branches, like this, and like most of them has 2 branches like this. So there are different types of trees. But within the context of this lesson, we will study all those trees that have maximum 2 branches. Like it can have one or maximum two. For example, uh, let's see like this. You see, every node has maximum 2 children, minimum one. So we will study binary tree, binary search tree, balanced tree, heap. Heap is a kind of tree that we use this to explain priority queue. I will explain this later when I explain queue and priority queue. For priority queue, we use heap, and then we will explain tries. So now let's start how we can represent these trees in programming. So let me create a new Java project. Let's say tree data structure. Okay. So see the pictures of the trees here. You know that every branch or every leaf are represented using nodes. So we have to create a class uh, to represent these nodes, and we should have one more class to represent the whole tree itself. That means there we should have one property named root, and that root has to point to the central or the top node. So a quick note: in order to represent a tree similar to linked list, you need 2 classes. One class to represent each node, and one class to represent the tree itself. So now let's write that. So you need one class to represent the nodes. Let's name it a node. And one class, the tree itself. Okay. So node. As far as we discuss only binary tree, so check the binary trees. Every node has, like, in binary tree, every node can have maximum 2 children. So what does that mean? That means when we are creating our node class, so we need to have two properties. One should point to the left node and the other one should point to the right node. So this property, this node has like two main properties. One is the node left, one is the node right. Okay, and one is the data itself, NAT data node. So whenever you create an object of this node class, you pass its data as well. So you say init value data equals value left. By default left is null and by default right is null. Okay, so now you are done with your node class. See, every node has three properties. One is the data itself, and the other two properties are the left node and the right node. So, and we should have the tree class itself. And the tree class itself, similar to the linked list, it has only one property, and that is the root property. That is how we access the tree. So we say node root tree root by default points to null. That's our tree class. So now, in order to do any operation with this tree, we are defining all those methods in this tree class. So now let me create one more main class. Main class, it should have the main method. See, if you represent a tree, let's say and let me find a small tree like this one. If you want to represent this tree, so here for example you have 1 node, 2, 3, 4, 5, 6, 7 nodes. That means you are creating 7 objects of this node class, and then you are connecting them like the right node, left node, and the data itself. See, every node has 3 properties. One is the data. For example, there's a node, the data is 50, and other property is its left node and its right node. So every node has 3 properties, and when you want to represent this one, so you have the class node, and like how we can access this like chain now. So we should have access to this root. That is why we have a class tree, and it has one property. The property is root. This root points to this root node. That is how we access the tree. So now if you represent this, you are doing it like this. Like let's have a node. So node 1 equals new node. For example, this should be 50, the root node. Let me copy this. Okay, so 50, there is another one 30, another one 20, another 15, another 10, another 8, and this last one is 5. So node 1, node 2, node 3, node 4, node 5, node 6, node 7. Okay, so you have 7 objects, and let's have the 3 object also. 3 equals new 3. So now we have all the objects, but still it is not a tree because nodes are not pointing to one another. So in order to make it look like a tree, so we make the root pointer points to the root node. So we say tree dot root equals to 50. 50 is node 1. And then this has 2 other properties. It points to the left and right nodes. That means n1 dot left equals to 30, and 30 is node 2, and n1 dot right equals to 20, and 20 is n3, like this. And then 30 points to 15 and 10. 30, that is n2. n2 dot left equals, it points to this node, which the value is 15, n4, and n2 dot right equals to this node 10, that is n5. And also this node points to these 2 other nodes, the 20, that is n3. n3 dot left points to 8, and that is n6, and n3 dot right points to 5, that's n7, something like this. So now it is this tree. You see that how the nodes are referencing to one another. So it is called root, and the last nodes are called leaf, like the tree. So I hope now it is clear for you how to represent tree in programming. But after this time, like when you are adding new node to your trees, you are not following this approach. Like you do not come here to first create an object and then do like this, like manual referencing to one another. So we are defining methods here in the tree class for each operation. For example, how to add a new node into the tree, or how to like traverse the tree, or like how to find a tree, or like how to remove one of these nodes from the tree, or all those operations. We are creating a method for each operation here in the tree class. For the moment, that's all. Here I just try to make clear how to represent a binary tree in Java programming. Until the next lesson, that I will start developing some methods to how to like insert or delete new nodes in the tree, and we will see all those methods later. Until then, have a nice time, everyone.